Okay, what's up everybody? Today we're going to be talking about direct variation, okay? This part of math has to do with taking lines, so linear equations, okay? Things that have no exponent on the x, so 5x or y equals, 10x or y equals negative x, it doesn't matter. This x right here does not have an exponent on it, and because of that, it is a straight line. Okay, technically is an exponent of 1, so I should clarify that, but let's just go with it for now, okay? I'm going to say some partial truths until you're ready for more. So fine, this has to do with this section of math, okay? If you're comfortable with linear equations, you may proceed. If not, please go back and watch the video I made on the basics of linear equations and graphing. You kind of need some of that to understand this part, okay? If you feel comfortable with linear equations, just the basics, then you may proceed, okay? Let's get started. Now, as we get started, I want you to remember that it's very important to only watch like one example. Then literally pause me for the rest of this stuff and work it, okay? That's where all your strength comes from. It comes from working the problems. Watching will only make you feel good, and then when you get to the test, nothing happens. You must work it. It's just like going to the gym. Watching somebody else run the treadmill, lift weights is like, oh yeah, I could do that. But you don't get muscles until you lift them yourself. It's the same thing here, okay? So without further ado, here we go. Let's first start off with this example, okay? I'm gonna take two lines here and graph them here for you. Let's set up our graphs. Okay. And in both of these graphs, I'm just going to draw a straight line because we don't actually have to have points to start off. Okay, or here, let's do a different color, shall we? Ooh. Ooh. Okay. And let's actually take this line, move it down just a hair. Okay, that's super important. All right. All right. One of these graphs is a direct variation, and one of these is not. Okay. What we're going to talk about is how to tell the difference and what it means. A direct variation, or rather, two variables that have a direct variation with each other depend on each other completely, okay? So how you can tell if something directly varies is if you need the x in order to be anything. So if the x is 1 in this case, then the y is 4. And if the x is 2, then the y is 8. But notice this. If the x is 0, then the y is 0. For direct variation between two variables, and that just means two letters, the y must, here, let me write this, completely depend on the x. Okay? Let's have a look at what that looks like when it doesn't. So y equals 5x plus 10. Okay? If x is 1, then y would be 15. If x is 0, then y would be 10. Notice the y still has some other value. The y did not come out 0. Because of that, this is not a direct variation. And in this one, when x is 0, y is 0. And when x is 1, y is 4. When x is 2, y is 8. So it's still increasing by multiplying 4. this is a direct variation. Okay? Again, the reason this is this equation right here is increasing by 4. And when x is 0, y is 0. You have to have both. The increase must be by the same amount. And when x is 0, y is 0. This is your keeper right here. If you can remember this, you literally have direct variation for the most part. We're going to talk about y equals kx. We're going to talk about how to read a graph, how to apply it, all of that. But if you can get this right here, you are okay, 100%. Okay, let's have a look at a few others. Y equals 10x. Ask yourself, does it increase by the same amount? Let's find out. When x equals 1, then y equals 10. When x equals 2, then y equals 20. So it's increasing by the same amount, 10. When x is 0, does y equal 0? And yes, it does. Y equals 0. This is a direct variation then. Okay? And when we say this is a direct variation, what we're really saying is y varies directly to x. Okay? So ask yourself, does it increase by the same amount? And is y equals 0 when x equals 0? You need a yes to both of these. I was trying to highlight y'all. You need a yes to both of these for it to vary directly. Okay, let's have another example of when it doesn't. Y equals 10x plus 10. You know why? This part right here. Notice that when x equals 1, y will be 20, and when x equals 2, y will be 30. So although they're both increasing by 10, when x equals 0, y equals 10 in this case. That is your red flag, guys. This right here. When x is 0, y wasn't 0. Y was something else. Another funny way to think about this is when x is 0, y moves on with its life. It doesn't go to 0 with x. Okay? So, in this case, you could almost say that y is pretty unreliable. When x has nothing, y goes on having something without x. So, y does not vary directly with x here. Because if it did, y would be 0 when x is 0. Okay? You want to look for those two things. Does it increase by the same amount? And is y 0 when x is 0? Okay? Let's have a look at an example of one that is when x is 0, y is 0, but it doesn't increase by the same amount. Let's have a look at what that looks like. Now, you're not actually going to run into this in your current chapter because it's not linear. But y equals x squared is a perfect example. If x equals 0, then y would equal 0 for this. But if x equals 1, then y would equal 1. And if x equals 2, then y would equal 4. And if x equals 3, then y would equal 9. These are not increasing by the same amount. Even though x is 0 and y is 0. Okay? So when you're dealing with when you're talking about direct variation between two variables, it's, for our purposes, it's linear. It's linear. So you need no exponent on that x. It needs to be a regular x, and it needs to be increasing by the same amount, and it needs to be when x is 0, y is 0. Okay? Let's try a couple. And by the way, let me give you this shortcut. Some of you may have already seen it. The minute you see something else out here next to that number and x, it's already not direct. If you subtract, add, if you do anything else to the x, it's not direct anymore. The only real way to have a linear direct relationship between two variables is for it to be alone. Y equals 10x and no one else. Okay? That sounds quite depressing, actually. Okay? The only way for it to have a direct variation is for it to be alone. So let's just go ahead and call that a mental shortcut. Look for equations that are lonely. Okay, here we go. All right. So you should look for things that say like y equals 10x. That is a direct variation. Y equals 2x. That is a direct variation. Y equals negative 10x. This is directly varied. Y equals 5x plus 10. Not alone. Not direct. Okay? Here, let's put a giant red X on that. All right? So with that in mind, now you try a couple of practices. And again, this first part should be super easy because now that I've given you that, you can look at these and pick it out. Give it a shot. Y equals 4x. Y equals negative 2x. Y equals negative 3x plus 3. Y equals 1/3 x. Y equals x over 10. And y equals x plus 3. Try these. Go ahead and pause me and literally just answer with yes or no. So yes equals direct and no equals not direct. Okay? All right? Give a pause and give it a shot now. All right, if you haven't paused me yet, I'm getting ready to give the answers because I want to make these videos shorter for y'all. That means I have to give less like work time. But you can pause me and take all the work time you need, okay? All right, here come the answers. So hopefully you looked at these and said, okay, anything that doesn't have a plus or a minus next to it is direct because you're multiplying it or dividing it by the same amount, so it's going to change by the same amount. So it's directly related. So this one is a yes. Okay, it's increasing by 4, and when x is 0, y is 0. This is a good to go. This is a yes. When x is 0, y is 0, and it's increasing or decreasing by negative 2 here. So that's a yes. This should be a no, because when x is 0, y is 3. That is not a direct relationship, okay? Okay. Here is 1/3 x. Some of you may have looked at it and been like, no, that's not it because fraction. No, baby. Remember what I said. Unless it's got a plus or a minus something out to the next of it, it's direct. This right here is increasing by 1/3 and decreasing by 1/3. So it's increasing and decreasing by the same amount. If x equals 1, it's 1/3. If x equals 2, it's 2/3. It's the same amount. And if x equals 0, then y is 0, because 1/3 times 0 is still 0. So this is a yes. This is direct. Same thing here. X is getting divided by 10 no matter what you do. So if x equals 1, then y equals 1/10. And if x equals 2, then y equals 2/10. Increasing or decreasing by the same amount. And when x is 0, y is 0. So this is indeed a yes. Okay? This right here should be a no, because there's a giant plus 3 here. When x is 0, y is 3. That is not direct. Okay? in terms of looking at equations, this is a super easy way to sniff out if something is direct or not, okay? Now, try another 4, and then we're going to take this to the next level. I'm going to introduce k to you and show you what to do with that. Try these. Y equals 5x, y equals 2x minus 3, y equals negative 2x, y equals x divided by 10 plus 5, y equals x divided by 10, y equals x squared. Pause and try. Okay, here come the answers. If you haven't paused me, now's your final warning. All right, let's do it. So on this one, when x is 0, y is 0, and it's changing by the same amount, 5. So this is a yes, okay? On this one, when x is 0, y is negative 3. So that's going to be a no. X and y should both be 0 at the same time. Even though they're changing by the same amount, x and y are not 0 at the same time. That's a no, okay? For this one, when x is 0, y is 0, and it's changing by the same amount. When x is 1, y is negative 2. When x is 2, y is negative 4. So it's changing by the same amount too. This is a yes, okay? Because when x was 0, y was 0. How about this one? This should be a no, because when x is 0, y is 5, and x and y have to both be 0 at the same time. Okay? How about this one? This should be a yes. When x is 0, y is 0, and it's changing by the same amount, 1/10. Okay? How about this one? Trick question. Even though on this one, when x is 0, y is 0, and even though they seem to change by the same amount, they don't. Remember that when we talk about direct relationships, we should be talking about linear equations. So there cannot be this exponent on the x, okay? So this one should be a no. All right? Okay. There'll be more practice problems at the end, but we need to go ahead and move on. All right? So hopefully by now you can sniff out how to tell if something is direct or not. It should be a lonely equation, okay? Meaning it should be y equals something times x. That's it. Nothing else. It's lonely. Okay? Y equals something x. Got it? Since this is the definition of an equation that has direct variation between the two letters, then whatever number is here doesn't matter. It doesn't matter if you put a 5 here, or a 10 here, or a 1/3 here, or a -5 here. It doesn't matter. Whatever number is here simply tells you how much it's going up by. You already know it's direct because there's nothing out there next to it. The number in front tells you how much it's changing by. This number in front, we give a special letter called k. And this stands for the coefficient of, I'm trying to remember, the coefficient of, actually, I don't think it stands for coefficient. It's like the proportionality constant or something like that, all right? So look, just know that this k, and I'm going to misspell constant on purpose. It means that constant, I think it's proportionality constant, okay? You don't have to remember this name per se, but you do need to remember this letter. It's very important. It will show up on your ACT. It will show up on stuff, and it is free points, because when you see k, all they're really talking about is what number is in front of the x. And when you see k, you should automatically think to yourself, there's some number in front of x, and that number in front of x has nothing else next to it because it's lonely. Okay? Let's have a look at a couple of these. So here, let's just work on while it's still in our view. Y equals 2x. What is k? k is 2, because k is the number that x is increasing by. Take a look. Or that y is increasing by, sorry. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. This stuff is increasing by 2. And 2 is what k is. Okay? Remember that when you do this k thing, you should only be applying it when it's a direct variation. And we have a direct variation anytime the equation is lonely, as in there's nothing else on the side. So if I gave you something like y equals 5x minus 10, there is no k, because this is not direct. Okay? For this to be direct, you'd have to not have anything out there. Now k equals 5. Because k is how much the equation is dependent, or sorry, how much y is dependent on x. And y is only dependent, truly directly varying dependent on x when there's nothing else out there. When x is 0, y is 0. That's the only time you get to do this k thing, okay? So fine, k then, in this case, is 5. All right, now you try. Y equals 10x, what is k? Y equals 1/5 x, what is k? Y equals x over 10, what is k? Y equals negative 2x, what is k? Y equals negative 5x minus 5, what is k? Rewind the video if you need to. Otherwise, you can go ahead and pause here and work the problems. A few more minutes here, and then I'm going to go ahead and give you answers to keep these videos kind of succinct. Okay, hopefully you're ready. Here we go. First of all, make sure that this is directly related. This should be a lonely equation. There should be no plus or minus anything. Okay? All right, if that's true, then the k for this one should be whatever number is in front of x. And it looks like that number this time is 10. So k is 10. Okay? There should be no plus or minus anything for our next one, and there isn't. So this is a direct variation. When x is 0, y is 0. So the number in front of x then is 1/5. And that means that this is y is increasing by 1/5 every time x changes by the same amount. Okay? Or increases by 1. Let's take a look at this. Okay? Now, don't be fooled. X over 10 is the same thing as 1/10 x. If you need to rewrite it like that, rewrite it like that, because this is a lonely equation. It is 0 when y is 0, or sorry, when x is 0. So the k for this is 1/10. Okay? Don't be thrown by division or fractions. It's all about, is there anything else next to it? Any pluses or minuses? If so, it does not have a k. If there is no plus or minuses, fine. What is it being multiplied by? If your x is part of a division problem, it's being multiplied by a fraction. Just show the fraction and you got it, okay? How about this? The k for this should be negative 2, okay? Because that's the number in front of x. All right? And then our final one. What is the k for this? Catch. Hopefully you caught this. Not applicable. Why? Because this is not a direct variation. There's a plus minus out here. So there should not be any type of k for this, okay? Hopefully you got those. If so, you are almost home. All right? Let's have a look at what this looks like on a graph. Notice that when you graph lines, that when x equals 0, y equals 0, that those lines always go through 0, 0, because 0, 0 is when x is 0 and y is 0, right? Any straight line that goes through the origin, let me write that out, any straight line going through 0, 0, aka the origin, is directly varied, meaning it is a direct variation. This is also sometimes called directly proportional. Okay, these both mean the same thing. Okay, in fact, in the form, you know how we've been finding k? That k stands for the proportionality constant. So they used the word proportion for this because proportion and direct variation are the same thing. Directly proportional and directly varied are the same thing. Okay, so for graphs, you're looking for lines that go straight through 0, 0. Contrast that with this bad boy. This one is, here, let's do a different color. Not direct. And this one down here is direct because it goes through 0, 0. All right? I'm going to give you a couple of lines with absolutely no equations whatsoever. I want you to tell me if they're directly varied or not. Again, you're just looking for a straight line, not curved, because remember, if it's linear, then it's increasing by the same amount. And if it's increasing by the same amount and going through 0, 0, it's got to be directly varied between the two letters. Okay? Let's try a couple of these. And let's make a couple of copies of this graph too, so we've got more to work with and y'all don't have to spend so much time waiting on me to draw. BT Dub, those of you who are super comfortable with numbers, recognize that I'm using exponential growth to make these lines, or make these graphs. By creating 4, then I took the 4 and copied those, and so now we've got plenty. All right. All right, I think 8 is enough. We won't be greedy. We won't be greedy. Yeah, we will. We'll be slightly more greedy. Here, let's grab one more set, because it can't hurt to have more practice. It really can't. It can only hurt to not have enough, okay? All right, so here we go. Ready? You tell me if these are direct or not, simply by looking at the graphs. No numbers needed. Ready, set. Remember, you're looking for straight lines that go through 0, 0 if they're direct, because straight lines are increasing by the same amount or decrease. They're changing by the same amount, okay? And go through 0, 0. You need both of these for direct relationship, okay? In fact, you can screenshot this right here and this will get you through everything, okay? Ready, set, let's try it. Feel free to work these in real time too. I mean, you should be able to kind of just look at these and just tell what's going on. Not a bad concept at all. Now, if I'm going too fast for some of you, just pause this video and work through them as you go. I haven't given the answers yet, but I have a feeling some of you can literally just look at these and answer it, and if that's the case, I'm going too fast. But otherwise, just wait for me to finish drawing these, and then you can or actually, I mean, just pause me as you need as I'm making these. So rewind the video if you need to and pause me as you need and work them as we go, because I'm just going to give the answers as I talk, as we go down. All right, so pause me now if you need to. rewind me and pause me on each of the graphs so you can answer these, because I'm going to go and get the answers going down. All right? If you haven't paused me yet, please pause me. If you haven't had a chance to work it, you need to work these to gain the confidence, okay? All right, here we go. This one is not direct. It doesn't pass through 0. This one is not direct. It does not pass through 0. This one is direct, okay? And when I say is direct, what we mean is these two variables are directly related, okay? All right, these are directly related. These are not directly related. These are directly proportional. And it looks like in this graph, these are going down by the same amount. So it doesn't look like it's increasing, it's going down by the same amount, okay? This one is shady. If you said yes, it's because I got kind of close to 0, I'm fine with that. And if you said no, because it doesn't perfectly go through 0, that's actually a little more accurate. So I'm gonna leave this one up to you depending on how you interpreted my not accurate drawing, okay? This one should be an absolute yes. It goes through 0, 0. It's a straight line. This one should be a no. It's a straight line. It does not go through 0, 0. This should be a no. It's a straight line. Does not go through 0, 0. It should be a no. It's a straight line. Does not go through 0, 0. This should be a yes. It's a straight line, and it goes through 0, 0. Okay? Question. Let's erase some of this. Hopefully you got those. I kind of just flew through that. If you need more explanation, rewind the video, because I think I laid the foundation pretty well. All right, take a look at this. Is this directly related? And that should be a no. It's not a straight line. Tell me this. Is this directly related? No, not a straight line. Okay. How about this? Okay. No, not a straight line, and it doesn't go through 0, 0. Okay. All right. How about this? Okay. No, not a straight line. Okay. Hopefully, you know, it's kind of obvious. All right. Okay. So, what does this look like in a word problem? We will look at that in a separate video. I just wanted to lay the foundation for you here. We'll work some actual word problems on part 2 of this, where we'll read through word problems and you can start picking it out. But this should set a pretty healthy foundation. Just remember that for these type of equations, it's always a lonely equation, and that lonely equation is defined by y equals something times x. And that something can be anything because there's nothing else out here. Okay, there's nothing else out here. So whatever number is here, we call the letter k. So y equals kx is your equation for directly varied variables, or direct proportion. Okay, and k is whatever number is in front of x, and that number in front of x tells you the amount y is changing by every time. Okay, except 0 because when x equals 0, y equals 0. All right, that should be your a pretty good summary there. All right, so we'll pick up with word problems next go around. This should set the foundation for you. If you have any questions, come by and see us. Do not wait till the day of the test. Don't wait till the day before the test. Come see us today. If you're seeing this on Tuesday, come see us today. Okay? If you're seeing this on Monday night, come see us tomorrow. If you're seeing this on Wednesday, come see us super today, because tests tend to be a few days away from when you first see it. So I want you to make a habit of coming and getting it, you know, under control fast, so that you're never stressed out And even if you need help the day of a test, it's not your first time learning it, so you actually have a chance, okay? Hopefully that's helpful. If it is, let me know in the comments, and I will see you on the next part, which I should be able to release tomorrow afternoon. We don't have a meeting tomorrow, so I should be able to get this out earlier. Okay, see you later. Have a good night, and